Hello, folks. We're back again for another 2 hours of fun and excitement, or at least computer programming, which counts as fun and excitement in my world. We're going to be focusing again on evolutionary computation and Rust. So we started this 2 weeks ago. Didn't do it last week because of family stuff, but we're back in again tonight. So I'm building, at the moment, a very simple evolutionary computation system in Rust. If things seem to continue to be interesting, I will plan on expanding it to a more complex evolutionary computation system. We're actually evolving computer programs. And one of the goals here is to compare performance between Rust and Clojure. And in some ways, Java, we could do this directly against Java. I don't know if I care that much, because I'm not likely. So I've been most of my evolutionary computation programming in the past. So that's my research area, and so in the past 10 years has been mostly in Clojure, and that's been worked really well in a lot of ways. But it is we spend a lot of time waiting for things to finish running, and so I was curious to see how much faster things might go in Rust, and the early indications are maybe an improvement of like a factor of 100, which is a lot. So I'm sort of building up, sort of trying to make reasonably comparable versions of things in both Rust and Clojure to do timing comparisons. And as long as the comparisons continue to be interesting, i.e. Rust is outperforming Clojure by some meaningful amount, and I would certainly consider a factor of 100 a very meaningful amount. I don't know that we'll maintain that, but it's certainly been impressive so far. Then we'll keep going and see what we can figure out. So we're going to pick that up where we left off 2 weeks ago. And so the thing I want to focus on tonight is trying to parameterize, as it said on the title, recombination and selection. So this is the next generation function in my system. So this is an impl in population of vector of booleans. So there's a type bit string, which is a shorthand for vec of bools. So this is a population of bit strings. And we've implemented a method, next generation, that takes a reference to the previous population and is going to generate a new population from the original one. It currently takes a compute score function, which is a something that implements fn, which is a Rust function trait that takes a reference to an array of a slice of booleans. So in a reference, and I'm going to talk as if these things make sense. But if you're new to Rust, and I'm saying things that don't make sense, absolutely stop me. And I would be happy to explain what some of this stuff is. But so this is basically a slice of booleans. It's really a pointer into an array of booleans. And it's going to return an i64, so a 64-bit integer. So I'm currently using i64s as my scores. I don't know if that's a great choice. Actually, there probably is a good argument for parameterizing everything over the score type. And we're going to need to do that to implement lexicase selection, because its score type is going to be a vector of things. But I haven't done that yet. So that'll come up. I don't know, kind of doubt it'll come up tonight, but you never know. At some point we'll have to generalize this. And the send and sync are there because we're passing these functions. So really the way to read this is that this is a thing. So compute score implements this kind of function, and compute score has the send trait and the sync trait, and that's so that we can send them back and forth across threads, because we're doing the next generation in parallel in ways that we'll see in a second. So we get the individuals from the previous generation. We assert that that is not empty. And that is so that we can unwrap in a few places down below without having to worry about the unwrap ever actually doing a bad thing. I compute the population size so I don't have to recompute it, although it looks like I only ever use it once, so maybe I really didn't need to do that. Well, yeah, we'll leave it there for now. So then this is going to be the new set of individuals, and we can see down here after we've built that new set of individuals, we generate a new population with individuals as the one field in this struct, and that's what gets returned here. So then building the individuals, we take, actually I think I like this better here. Actually I think I'm going to do this. Yeah, okay. So we have 0 to pop size. We turn that into a parallel iterator. So this is from the rayon crate and means that it will process this iterator in parallel in some magic way that takes into account the number of cores your box has, and attempts to parallelize the process. And my experience is it parallelizes very well, with basically 0 effort on my part, which is totally wonderful. Absolutely love that. And then map init. So basically we're mapping across all of these numbers, 0 to pop size -1, and for each one of them we're going to make a new individual. And we're going to do that with map. So we're going to take the I as a reference to where we are in this list. Turns out I used that in one place. Map init lets you initialize a value, which is then passed in as the first argument to the closure or the map operator. And that's useful here because we want to get the thread RNG, random number generator. So basically this gets us the random number generator for this thread, which can be different depending on what into par iterator is doing. And then if I is equal to 0, I mean, actually probably ought to reverse the order of these things. But if it's equal to 0, we actually just get the best individual and clone it and use that. So the first slot is always just a clone of the best individual from the previous generation. And this is a thing called elitism, and it ensures that we never lose the best thing. And otherwise, we're going to get a randomly chosen individual from the previous population, and the best individual from the previous population is the second parent. We're going to cross them over using a thing called 2-point crossover, and then we're going to mutate the result, and that will be the child. And this bit of the code, this is really all kind of a mess. And this is what I want to try to clean up. And there's 2 versions of it being a mess. One is actually a performance version. So we pass the scoring function into both 2-point crossover and the mutate, and that causes the result of doing the crossover to be scored, That score is then thrown away and replaced later by the score we get based on the mutated version of things. And that's just silly because the scoring's often the most expensive part of the process. Doing it multiple times is dumb. So separating the bit manipulation of crossover and mutation on the one hand and the scoring on the other, those two things really need to be separated. And right now my operators are doing both. I'm combining concerns in a way that's totally unhelpful. So that's bad and needs to be fixed. The other thing that's bad and needs to be fixed is, as you can see right here, this is me playing around with different ways to select parents and to do mutations and crossovers. And we're just like commenting out different lines of code. This is awful. We really need to parameterize this so that we say, when we call next generation, what selection tools we want to use and what recombination tools we want to use. And then it would use those things that are passed in here down in this place, and we wouldn't have this nonsense. So both of these things really ought to be changed. I think I want to start tonight by trying to split out the bit manipulation and the scoring, because I think that will then simplify parameterizing the other parts. If we don't do that, the parameterization of the other parts is going to, like the bit manipulations are still going to end up taking compute score as an argument, and that would be unhelpful. So I think we want to do the splitting first, and then we'll worry about parameterizing things. So, any questions, comments before we get started? Doodly-doo, doodly-doo. Okay, well, let's do this thing. Okay, so let's look at 2-point crossover. That's so actually I have a yeah, right here. So I have an individual bit string. So impls for individual bit string that include uniform crossover, 2-point crossover, mutation 1 over length, mutation with rate. And these are currently attached to individual bit string, but they probably ought to be in bit string, not implemented on bit string directly, not on individual bit string. It doesn't really make sense for them to be on individuals. Now, there may want to be some other, you might want some things here as well, but there's going to turn out to be an issue with that. So let's actually start by just moving them to bit string, and then we'll come back to individual bit string and see where we end up. So I've got bit string. Oh, right. I can't impl on bit string. Forgot that. So it turns out, because bit string is really just a renaming of vec bool, you can't impl bit string on anything because you can't define impls for types outside of the crate where the type is defined, and yada la la la. So this just doesn't work because all of this is defined somewhere else, and you can't add things. So really, this is impl vec bool, and they won't let us do impl vec bool. And I could fix that by making bit string a wrapper around vec bool, and then I could implement a from that would convert a bit string into a vec bool. I wonder if that's really the right thing to do. It just seems it seems so annoying to have that unnecessary wrapper. But I think that's maybe just me not sort of getting Rust. And that the Rust way to do it would be to have the wrapper and trust the compiler to inline all the conversion so that it wouldn't really matter. I don't know if anybody else has any thoughts on this. I know there's some people with more Rust experience than me in the room. If anybody's got any thoughts, I would certainly be more than happy to hear it. Otherwise, maybe we'll. How much work is that going to be? Good question. Well, let's actually try it. Why not? So I'm gonna. Okay, so we're back to where we were. Make sure that I don't have any. What do I have this uncommitted? Oh, that was the respacing. Just commit that quick. Respace. Next. What did I call it? Next. Wah, wah, wah. Generation. Okay. Oh, sorry that you shouldn't be here, but it's wonderful having you, is it, Sue? So using a custom trait. Oh, I hadn't actually thought about a trait, I think. I'd been focused on I don't think I've ever made a trait. So trait, bit string. So I don't know that I know what the syntax looks like. Rust, custom trait. Traits, Rust by example, that'll do. So we have a trait. We specify things, but we can have default specifications. Interesting. You know, and another possibility, now that I think about it, can I... If I change this to T, it's going to be grumpy. Can I put a T? No, it does not like that. Just like that. Oh, okay, that works. Can I impl that? This is grumpy. So I could impl. Could I do this? Oh, I can. That actually, I think I like this. I like this better, I think, than a trait. Is because I might want. I guess they're not going to be bit strings then. So I have to change the name. But you might want genomes of things other than Booleans. And a lot of the functionality would still be the same. So, like, the crossover would probably be independent of T, whereas mutation probably isn't. So, oh, it didn't like that. Impl. Oh, that's right. I think I have to say impl T here. Yeah. Okay. So actually, I like this better, and then I can impl things on bit strings of different types. You don't think I can? Pub fun. Oh, so you think that because I've messed with bit string, I've got so many errors that, yeah, that's a possibility. Well, here, let's take this back to where it was. Boom. That all compiles. Let's just make a new pub type genome of t equals vec t impl t genome t. You're right. So good you're here. Who knows how far I would have gone down that road. It could have been real bad. So thank you. And I do appreciate that it's like incredibly late for you. So if you need to like bail and go get some sleep, I would completely understand. Well, that's annoying. Okay, so let's go back to your trait idea. So I could do a trait and maybe that's really what I want. Maybe the part of what I was doing kind of with this T thing was creating traits. So maybe if I say trait genome, I don't see an example with generics. Am I going to need to worry about that? Well, let's find out. So trait, and then I have curly braces and a list of functions. Okay. Let's get rid of you for now. Boom, 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 boom. And do I need... No. Okay. So that syntax seems to be compiling. That's a happy thing. And so... actually, I'm going to call this linear genome. Whoa. There we go. And I'm going to want to be able to implement... let's see what we definitely want the crossover. That actually should be the uniform crossover, and down here the 2-point crossover. Let's do the uniform crossover because that was already out in the universe. La 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 la. Oh, actually, but I didn't want to actually probably cut that yet. Well, we'll stick it right here for now. So I'm going to want to implement, and I just say FN because we don't have to worry about publicness. Uniform crossover that should take so we can take a, okay, we can take a reference to a self, and an other, which is a reference to linear genome T, which is actually just self, reference to capital S self, right? Yeah. Yeah, I don't know. I mean, I think that the trait idea may actually be the better long-term decision, because I think there are potentially, whether we get into implementing all these things in this project isn't at all clear to me, but there are multiple linear genomes, and they're going to have different implementations of some of the key ideas like mutation, because mutating a bit's different in a string of bits is different than mutating an instruction in a linear genome that it's a sequence of instructions. So I actually think a trait might be the right thing to do here. And so I'm going to like roll with that. And the fact that we can have default implementations is potentially interesting, because actually this is an example where I'm gonna probably want a so that's gonna take one of those and return a self. And now I think I can just grab all this, stick it here as the default definition, except for I'm indented incorrectly. Wada, 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 wada. Boom. There we go. So that, oh, hey, gotta have a lot of bad. So, oh, that's interesting. Yeah. Well, let's first clean up this business, and then we're going to have to come back to that guy, because I think that guy's going to be a challenge. So this is going to be self.len, and this is going to be other.len, and this is going to be self. I should have just done a renaming instead of doing this by hand. Oh, interesting. Of course, it doesn't know that this is essentially a vector. Oh, so maybe you're right about the type. Yeah, because we actually need to say something like impl. Okay, so let's actually get rid of all this. Let's just say this is that. Now, will that part compile? Yes. Now, impl linear genome bool. No, I don't want bool. T. So I want impl T linear genome. So I think I might, if I go this route, I may have to build out a lot of stuff, because I want this to, I want a linear genome to be a vector plus some other stuff. And if I was in a language with inheritance, I would say that linear genome inherits from vector, but that's not true here. Can I say that a trait implements another trait? I can, can't I? Impl trait. La, 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 la. I don't see where infiltrate is in this. Oh yeah, right. It's a return type. So we can return something that implements an iterator. But I can't implement on vect, right? That's what gets me into trouble. That if I say that, I get the problem because I'm trying to implement something on an externally defined Oh, so I would implement, oh, I see. So I could implement linear genome T, is it on or for? For, I think? No. Still grumpy. Sure. So that's just unhappy because I haven't done it yet. Oh, so maybe I could do this. Wah, wah, wah. So then I could grab this, drop it here, get rid of pub, and then I got to change the whole business. So I'll just grab this. Yeah, and this is self, and this is other self, oops, lowercase, learn to spell, self, and other, fingers crossed. No, did not like that. Cannot move. Oh, we don't know that T allows for copying. So if we, yeah, because we're copying elements out of the two, and that would be here. Copy. Oh, look at that. Okay. That actually, I think, is pretty good. I like that. I'm okay with this as a plan. Yeah. So then that gives me, I can have a vec thing, but call uniform crossover on it, and I'll still be okay. So let's see, where do we call uniform crossover? Actually, let's get rid of that. And that will actually give me, that will tell me where the problem is, because all of a sudden there won't be a place. Right there. So this, we should be able to say self.genome.uniform crossover, and we take the other parent.genome, and why are we grumpy here? Oh, we found a reference to a vec. Oh, I think that's because I got this ampersand here, which I don't need. Yep. And then, hey, we're good. And it all compiles. So that's nifty. Does it run? Let's find out quick, because that'll just make me happy. Cargo run. I've got a bunch of tests too, which I'll have to keep an eye on. But yep. So that, so that's a population of 1,000 individuals. So that's 1,000 strings of 128 bits. And that flew by very quickly. So that was good. I mean, I think actually, I've checked this. I think about half the time in running it in the terminal like that is the terminal I/O. If you dump the output to dev null, it becomes about twice as fast. So that looks like that worked. And that is nifty. And I like that. So I can get rid of this. And then I could put 2-point crossover in there as well, or a version of this. This is currently acting on individual bit strings. We don't want that yet, but so we want to impl 2-point crossover. Oops. And this is going to take self and other. And we don't want to compute score to be an argument. Let's return a self. Whoa, we blew up the world. Oh, that's because this is not specified up here. Oh, come on. What have I done? There we go. Thank you. So that will be like that. And now this will stop screaming at us. And now we have to... so basically the self.genome becomes just self because we're not... then we're going to clone ourselves. Then we're going to have other dot clone. Do I need that? I feel like I shouldn't need that. I bet I don't, actually. Let's comment that out for a second and see if I can make that work without it. Yeah. And then I just want to return genome. Okay. So, whoa, no, don't do that. So that goes away. These are old versions of things that should be removed. So, I compute the length. Do I need the length? Oh yeah, I use it twice. Okay, we'll go ahead and leave it. I clone ourself. If you were really clever, you'd figure out which genome you had kept the most. No, actually, it probably doesn't matter. So, clone ourselves, figure out where the two crossover points are. So those are done as two random values. The first is anywhere between 0 and len, and the second is somewhere between that first and the end. And that's, so I don't, this really should have been 0. So by having the second one be between first and the end, I was biasing the crossovers to be more likely to be at the end of the string. I think I was thinking I was being efficient or clever. I don't know what I was thinking. But that was pushing the crossover areas out to the end of the string in a way that is not good, not uniform. And it's really weird because I was kind of dealing with the fact that first might be less than second here, or first might be greater than second here, but I was preventing that from being even possible by putting first here instead of 0. But this is actually the right thing. And if first is less than second, then I'm going to take this chunk from this genome and replace it with the same chunk from the other genome. So I'm basically taking that chunk from the second genome and copying it in to the copy of the new genome. Otherwise, I want to go from second to first. I could, sort of an alternative, which actually might be cleaner. Actually, I think this is cleaner. If I say if second is less than first, then I can say let first second be second first. And that will swap the order, and then I just have to do this once. I can just do that one. And I know, so we now know that first is less than or equal to second. And so we can take this chunk out of this guy, replace it with that guy, and then return that. Does this return the thing? What does this do? It does not return anything. So we do have to then return genome here. Okay. Now I've done something bad. Oh, no. This was bad, actually. So this was, yeah, those are new variables. So actually I would have to do this. I would have to say mute, and then get rid of the let. Yeah. So that's kind of mildly annoying because I had to make two things mutable that you would have preferred to have not been mutable in some ways. But that will do. Yeah, that will do. Okay. So now I think that does impl 2-point crossover. And so now we need to find out where we were using it. Right there. So this was 2-point crossover on an individual, and it still needed to do the scoring here. So I'm going to just replace the genome computation and then leave the scoring there for a second and make sure everything's good. So let genome equals genome dot 2-point crossover other parent dot genome and RNG. Close. And then the rest of that's the same, and all this can go away. No, something is not compiling. Oh, actually up here, no, that's right here. Oh, this should be self, yeah, okay. Self.genome.2-point crossover. Other parent. Oh, I wanted to borrow. Yeah. Because I don't want to take ownership of the other parent's genome. Okay, that actually compiles. Actually, before we get too excited, let's run the code and make sure that we can still run and run the test for fun. The test will pass. So I think that looks good. Hot diggity. Now, those two things are general to any vec of t. They don't depend on there being booleans inside the vector. And so they make sense in this generic universe. And so let's actually commit that, because when in doubt, commit something that's been significant. So we created a trait and we implemented it for vector of t, and then we removed the crossover operators. Okay. So add linear genome of T trait adds, oops, a new linear genome T trait with 2 crossover operators, and implements that for vec of t. Since the crossover operators don't care about the contents of the vector, oh, you know what? We don't have this assertion down here. We probably should. I'm going to actually catch that quick. Self.len. Yeah. In fact, I guess if I want to be picky, we can reuse the len that we had. Okay. Don't care about the contents of the vectors, and so can act on arbitrary vec of t. Okay, we'll call that good, commit, and back over to here. Wah, wah, wah. Now we want to impl the mutations, but on bit strings. So we impled the crossovers on vector of t. So that means the mutations actually have to be a different trait. Because if I add the mutations to linear genome, then they will be required for all linear genomes, and we don't have a way of mutating an arbitrary vec t. Right? So if I add something, that will then fail here because this doesn't implement frog. So if I were to add the mutation operators here, that would actually break things. So this is really interesting. Like, this actually forces me to be clear that things that are crossoverable are different from things that are mutable in the same way. That's interesting. Or the other option is I could add a bound on t that says that t has to be mutable, and that there would then be a trait mutable that would be used to actually do the mutation. I wonder if that's the thing to do. So I could either have two traits, one that's the crossover-y stuff and one that's the mutation-y stuff. Or I could have a single trait where T needs to be mutable. Does it make sense to separate the two traits? I feel like in some ways it would be rusty to separate the traits, because there's a lot of little bitty traits in Rust. So I'm not 100% sure. Yeah. So I think that making two traits, I think I agree with you that adding the impl bound or the bound on T here is kind of annoying because it doesn't affect these two guys. So if I put everything in one trait, if I say that T has to implement some mutable, and this is terrible language because mutable means something specific in Rust, but some evolutionarily mutable trait, that doesn't have anything to do with this. And so I think the right thing to do, quote unquote, is to keep things as clean as possible. And if T doesn't need to be able to be mutated in an evolutionary sense here, then I don't want to sort of muddy up this trait with it. Now, that means linear genome is a bad name. So maybe linear crossover? I don't know. I don't know that I like that name. Linear crossover. I think one thing I don't know is whether trait names should be nouns or verbs. If you implement a trait, you're saying you have a property. A property is a noun. Well, it's really an adjective. It's a thing you can do. Well, I'm going to leave that there for now. Let me make sure that everything still works, just for fun. Yeah. Okay. So then I would need to have a new trait, and I feel like I probably even need modules here at some point, but let's not sweat that one right now. Trait linear mutation of, now here we could add the a trait of mutable. So can I just say mutable? And then I'll have to implement that. Mutable, cannot find that trait. Trait mutable T. And I guess that would need to be then mutable T. Yeah. But actually, is that supposed to be the same? Yes. Oh. T isn't actually used in the linear crossover trait. You know, you're right. That's super interesting. Oh, I hadn't even thought about that. And like Clippy had not said boo on this, which I'm a little over reliant on Clippy to have pointed this out. So really, I don't need the T, and I still need copy. If I tried to remove that, that would break. Ooh, undo. What have I done? Okay, that works. No, that does not work. Oh, that's because I put this back in my undoing. Now I think if I remove that, presumably something breaks. Copies the elements. Yeah, okay. Oh, but actually that says that all I need is clone? Is clone preferable to copy? Clone is more general than copy. Oh, and okay, I did need copy right here. It just got covered by the other error. In that way, okay. So we do need the copy there, but we didn't need it here. Well spotted. Now, then the question is, am I going to need all these? Maybe I don't really need. Maybe in the impl I'll need it, but in the actual trait, I probably don't. So I'm not sure. Let's get rid of you for a hot second. And let's get rid of all of this waffly waffle. And then the two mutation operators. Let's see this one first, because the other one just calls this one. Where were you? Here we go. Boop. Okay. So we want to get rid of the pub. We're going to want to get rid of that. We're going to want to take self, a reference to self, mutation rate. We don't want compute score anymore. We do want a random number generator. Okay. And now we're going to want to impl T linear mutation for vec. Oh, actually, we're going to say bit string. And now that doesn't work. Oh, yeah, I don't need that because I don't have an arbitrary type anymore. And now the problem will be that this isn't implemented. That will... Yeah, sure. That should fail. Oh, hello. Oh, I put a semicolon at the end. Okay, cool. Some unused things, but that's not surprising. So this all works. Yeah, so we get to keep our name. And we're implementing this specifically for bit strings. So, yeah, okay. So let's go find the actual implementation of that. That was up here. So the body is this code here. Well, actually, we'll just grab that code there. Go up and find our impl right here. Boom. Now I'm going to fix everything. So we don't need genome anymore because we're not a genome. Did I actually say that explicitly? I did. I think it was so the collect would know the right thing. Really, I should have used bit string here. And then I don't compute the score anymore. And I just return. In fact, I don't even need to return, to give this a name. I can just say that. All right, so self iter map. I take the bit. I compute a random number. If it's less than the mutation rate, then I flip the bit. Otherwise, I leave the bit alone. And that works. It appears to. And then if we come down to the code, we can't, this is in individual, yeah. So we can say new genome, replace this with self.genome.mutate with rate, and pass in the mutation rate and the RNG. Boom, bop, boom, boom, boom. Does this compile? It looks like it does. No, it does not. Mutation rate. I can't spell. That's better. And let's run our test. To be paranoid. Cargo run just to see it do a thing. Yup. Okay. That is awesome. And this goes away. Boom. And then this wants to move. I need a mutate 1 over length. So where's my thing? So mutate with rate takes a mutation rate. What percentage of the bits should be flipped as an argument. A very common in evolutionary computation technique is to use what's often referred to as the 1 over L mutation, or 1 over length mutation rate. So it takes the you don't specify the mutation rate explicitly, and it uses 1 divided by the length as the mutation rate, and that's proven to be pretty successful in a lot of situations. So, and it's easy, you don't have to think about it, and it seems to generally work well, so might as well include it, especially since it's pretty trivial to throw in here. So boom, and and then the definition is just you call mutate with rate with the right parameter and you're good. So right here, so we get rid of the genome part, and oh, we don't have compute score anymore. Yeah. Oh, this still has compute score in it. We want to get rid of that. And I left it in here too. That's why it didn't blow up when I included it down below. Okay, so you just provide the random number generator and you don't need to provide the mutation rate. So that's a simpler thing. One of the truths in evolutionary computation is that there's like a bazillion knobs to twiddle, and it's really easy. I should turn on the light. I'm getting to be a little Bela Lugosi here. It got dark. Fall's coming. The sun goes down. Time to move to New Zealand, where the days will be getting longer instead of shorter. One of the unfortunate truths about evolutionary computation is a million knobs to twiddle, and one of them is mutation rate. So if there's kind of a standard cooked-in approach that works well, it's nice to have it, so you can just be like, pass in the random number generator and don't worry about it. So now we want to find mutate 1 over. So here we're just going to get, this used to, oh no, this does still call this. Oh, interesting. Huh. Do I need mutate 1 over length to be in the bit string or not? Maybe. Yeah, let's stick to that. So if we actually follow the model down below, self genome dot mutate 1 over length, and then we don't need this, and we score. Let score compute score new genome, and then self genome new genome score. Do I like that? Oh, I've got a semicolon I don't want. Do I like that better or worse? Because that seems to duplicate this code a lot. So maybe I was better off before. And then I don't even have... So when you said you would leave it there, you would leave this code alone, or you would have gone back to the way it had been previously? You could have the individual generic over a T and add where clauses to the functions depending on the trait. So, okay, so leave this guy in the trait. So leave this as in the trait. And then where are we? Down. Oh, I've crossed it. Yeah, here we go. Sorry for the scrolling. And so here we would still do this. Because it uses the length, and if you used a non-vec type, it would work. So if you impl linear mutation for something that wasn't a vector type, like a linked list, or I don't know, some other structure that had a length, you could use that version of the length in the implementation, and you'd still have it down. Yeah. Okay, I will take that as a winning suggestion. And this duplication is small and not overly stressful, and might go away when we fix. Oh, actually, it probably will go away when we fix separating the scoring from the bit manipulation. Oh yeah, I could impl individual t. Yeah, I think one thing that isn't clear is if I'm even going to want these guys to be in individual left anymore, because this still makes sense, but probably actually want this to be, in a perfect world, that's in a trait too. But I'm not going to worry about that right now. But here, all of these implement a method that combines bit manipulation and scoring in a way that is awkward and probably unfortunate. And I think I kind of want to make them go away, I think. Actually, I should commit what I've got first, because I don't want to get too ahead of myself and mess something up. So this adds the linear mutation trait. So add the linear mutation trait. This adds a new linear mutation trait that collects the so far two mutation operators. Boom. Now, we go down to next generation. I would like to use two parents. So maybe, yeah, so it would be nice to say have one or two parents and have a like a vector of bit manipulations that we apply in order to yield a final bit manipulation or final bit sequence, which we then can score. So it'd be nice to be able to call this with something like individual new child, and we would take first parent, second parent, and 2.xo mutate 1 over length, and the compute score function, and the RNG. I think that's the kind of call I would like to be able to make. And the concern, well, there's so many concerns. One concern, so I definitely think I want this to be some kind of vector, that it could have 0 to n operators. This part, I guess I want a vector there, because I think I'd like my operators to take, if my operators took a vector of individuals or a vector of bit strings and returned a vector of bit strings, then I can deal with the fact that some things act on two parents and some things act on one parent. Otherwise, I don't know how to type these. Well, so yeah, I have a feeling that actually they are meant to be functions, and I have gone the long way around the house. And may need to function. Yeah, they may want to be functions. Certainly in Clojure they would have been. And this is a thing of like, am I thinking in terms of objects or am I thinking in terms of functions? And I know Rust doesn't do objects, but it does feel like I want to be able to pass in a collection of recombination operators where it's like do the first one, followed by the second one, followed by the third one, and that there would be a collection of selection operators that would populate this thing. Not sure, I guess, not sure how to make a pipeline in Rust and keep the type system happy. And that seems to be really kind of what I want here, is that I want to be able to yeah, great question. I think the answer is probably yes. Although I recognize that has consequences. But I think the answer is ultimately I do want them to be dynamic. I think that I want, trading my glass of water for my tea, which is now very cold, but such is the way of the world. I think it would be nice if the user, if we were building kind of a general purpose system, and certainly in Clojure this is very doable. And so this is part of what I'm trying to like wrestle with, is the just where the two languages are stronger and weaker, you would be able to say, here's a kind of pipeline that's going to take some parent individuals and process them and spit out a new individual at the end. And in Clojure, you wouldn't have to worry about the typing. You'd just be like, it takes some stuff and it does some stuff, and if things don't work out, well, runtime error. Who cares? In Rust, it would be nice if we can like leverage the type checker as much as possible. And I'm not sure the best way to do that here. I mean, we could certainly have a vector of individuals go into here and comes out a vector of individuals, which goes in here, which comes out a vector of individuals, and then you could have a bunch of assertions. So have an enum of operator types. And are you, actually let me back up a second. Are you suggesting, where's a place where I have FNs? Actually the scorer is an FN, right? Yeah. So this impl FN, are you suggesting that having a enum instead of that kind of thing? I'm not sure I follow how that would work unless I can define all my scoring functions in advance, and that's not really feasible. Like every problem has its own scoring function and people invent these things willy-nilly. So if you're trying to make anything that resembled a general purpose library, you'd have to be able to let them implement their own scoring function and pass it in as an argument. But that may not be what you meant. Maybe you meant something here as being an enum. And that's possible. In some ways, they really ought to be also FNs, which I realize that's totally not what we did up above. But in some ways, they probably ought to be FNs because people invent new operators as well. And so in some ways, this probably ought to take a pipeline of operators and a scoring function and ways of selecting parents, all as arguments, so that people building their own systems could say, I want to use this selection mechanism to choose parents, and I want to use this combination of crossover and mutation to generate children. And I mean, you really want to get fancy about it, these things probably ought to be probabilistic. Like I might have 3 selection operators and I want to use A 10% of the time, B 80% of the time, and C 10% of the time. And there ought to be a way of saying that. That's not where we're going right now, but in a perfect world, that would probably be the sort of thing we would do. Now we could probably get away with think this would be legit. We could probably get away with having the first operator possibly take more than one parent bit string, and that all other operators take just a single bit string. Or we could even have, there is, the design here gets real awkward, potentially. And this is, I would argue, a place where like closure is nice because it doesn't make you think about this stuff. You can just be like, yeah, we're going to call some stuff and pass some things around and it'll all work out. And Rust is going to force me to be a lot more thoughtful about the design. And yeah, so we could take a is there an iterator kind of way to think about this? Yeah, I think of it more as sort of function composition than iteration. And function composition, I've actually looked this up, and there are suggestions on like Stack Overflow for how to write a macro, I think, that composes two functions. I wonder if actually macros are the thing to do here, because one of the things that and boy, that would be bad because I don't know nothing about Rust macros, other than they tend to have exclamation marks at the end, but I've never actually written one or even thought very hard about them. But if you, like, let's say you had a sequence like this passed in, or you were building, let's say you were building sort of a pipeline out of two things like this. In the macro, I think you could ask this how many parents it needs, maybe. But then that would have to be, we'd have to have like a proper trait thing. Not going to be able to ask that kind of question? Yeah. Poop. Well, okay. It's 8:30. I need to make a decision about how much I want to think about this and how much I want to think about this now. I'm clearly thinking big complicated things, which are not probably the simplest thing that could possibly work. So maybe I need to back up for a second and focus on what's the simplest thing that would accomplish the desired task of separating scoring from bit manipulation. And actually, if I were just to cook in 2-point crossover and a mutation operator and not even make those selectable, then that would simplify things for now. And I can maybe focus on the question of separating the scoring from the bit manipulation. And that's something I think we could do in half an hour. So maybe we do that, recognizing that that isn't awesome. And then we can maybe focus on passing in scoring selection functions as an argument. And then we could come back to this question of creating a pipeline. And maybe between now and next week, I could do a little reading and see if there are suggestions on how to make pipeline-y things like that in Rust. Because I feel like that's a dark forest and it has wolves, and I don't have the armor for that quite yet, so maybe that's not the best way to spend our time. So let's just bake in this sequence of events, and we'll try to do something fancier with selection. Okay, I think we'll do that. So we've got our first two parents, and we need to have the child genome be the first parent genome dot 2-point crossover with the second parent genome dot mutate 1/length. Boom. Oops. Now, yeah, I think that I good point. I will definitely do that. When this wraps up, I'll post sort of the state of play under the under the Evolutionary Computation channel. And for those who aren't aware, I think I forgot to say at the beginning, this QR code over here on the left is an invite link to the Discord channel. And if you would like to follow along or share cool ideas as we try to figure this pipeline thing out, that would be awesome. So why are you being grumpy? Oh, I just need to pass a reference because don't want to take ownership. So that creates the child genome. And so then I can create the individual out of that an individual has a genome and a score, right? Oh, I guess that was, oops, come on, it's over here. Genome and a score, yes. So we can say genome, child, genome, and score, compute, score, child, genome. And that gives me that individual, accepted. Oh, I need to pass a reference again. Whoop, no, that was not the problem. Do I have to clone? No. Oh, it's because I've done so I have to actually compute the score first. Let score be compute score child genome. Boom. Let me just have score here. Yeah, that's better. And in fact, if I just called that genome instead of child genome, then I could get rid of this piece here. Oh, and this piece here. Should have used the rename tool. So I think that will do the thing. Run the test. Test pass. Run the thing. The thing runs. That's very happy. So we could get rid of, get rid of this. So I think that's, if nothing else, probably made it faster because we're only scoring every individual once instead of scoring twice. This still isn't very flexible and could lead to a lot of copy pasting stuff, but one thing at a time. So let's commit that change. So separate the bit manipulations from the scoring. Uses the new mutation crossover and mutation traits to do the bit manipulations, and then only does the scoring once at the end. And this is an example, like, it would be nice if all of this could have been in individual, but for that to happen, I can pass in compute score, no problem, but I'd have to have some way of passing in this sequence of events. And so now I could have, I could just bake these in to some new child thing in individual, but I'm not sure that, it doesn't really move the lump anywhere interesting. Okay, so let's see if we can sort out the selection thing. So I feel like we do want to be able to take a vector of probabilities and selection functions, and then select parents based on those probabilities and selection functions. Now, is this a problem I want to dwell on now? Well, I think we're going to need to start it at some point, so let's start it now. So I think here, I'm actually going to make a new hub fn next generation with selectors. It's going to take self. It's going to take a vector of, I'll say F32 and impl F, and we're going to take a slice of individual, and we're in bit string. I'm going to scroll this up a little bit because we're in impl population bit string. Yeah, so we're focusing on bit strings here. So we're going to take a function that takes a slice of individuals and returns a reference to an individual. Yeah, I think we want a reference. And I need a thing there. Oh, and I'm going to need the random number generator in this function because selection is stochastic. So I'm going to need a what's my type here? I only do this a million times. Hello. RNG and mute. And, whoa, where am I? Yeah, okay. And mute thread RNG. So we're going to take an FN. Wow, this is going to get really long. Let us break this out so these things are not completely nightmarish. And what else does this take? And a compute score. We'll just copy that. Wah, wah, wah. And then boom. And that's going to return self. And if I do like self, there's a thing that I can use to say this isn't done yet. What is that? Rust return for unimplemented function. Unimplemented, bang. Haha. That's probably what I wanted. Or to do. Oh, actually, I even like to do better. Oh, it takes arguments. Fine. Okay. So, you said I need a box depending on whether you want to support capturing closures or not. So the concern is that the vector, whoa, I seem to have just a raw syntax. Oh, yeah, duh, you just want to type, you don't want to name. Because there's a function that takes those two things and returns that. And I probably did mean to end the type parameters there. And now we're grumpy about bitstring. Cannot find type bitstring in this scope. Oh, that's because I spelled it wrong. Does not have a capital S. And we don't like, oh, lifetime specifiers. And that's the only thing it's fussing about at the moment. So we're returning a reference, but we don't have a lifetime. But the lifetime ought to, no, it probably could just return an individual, but it feels like it ought to return, if I don't return a reference, I'm going to have to construct a new individual, and really I just want to return a reference. I think feels like the right thing here, because the selector is saying use that parent, that individual as the parent, and we won't ever have to like own it or change it. It can stay in the old generation. We're just going to look inside and copy some stuff out of it to make the children. So I do feel like references are the right thing here. And I feel like this is a lifetime problem we ought to be able to solve, because the lifetime of this individual should last as long as the lifetime of... Oh, actually, I've got all these. Yeah, it should last the same time as... No, not even self, because that's the new population. It should last as long as the old population. So this lifetime ought to match the lifetime of that guy, I think. So that's like this? No, wrong syntax. Is that just that? No. I need to introduce the lifetime. Is that here? La, 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 la. Oh, is it the lifetime from the selector's input? You know what? You're right. Maybe? I mean, yes. And maybe that's the right thing to do, because when we implement the functions, we probably need the lifetime of the return type to be related to the lifetime of one of the arguments. And so that's probably right. Yes, I think you're probably correct. That it's probably not this. It's probably... Now, can I do that? Use of undeclared lifetime A. So I need to introduce a lifetime somewhere. And so your suggestion is replace the impl function with boxdine for like that. Oh, I probably need another. Yeah, that probably needs to be here. No. So closing the box. And the box goes after the whole function. So I think that's the right place to close the box. Oh, and then this we would be, say, A. Does it compile? Oh my gosh, it compiles! I'm terrified. That is kind of crazy. If that actually worked, that would be sort of miraculous. Wow. Okay. Well, that could be a thing. Now, I'm going to want a function that does the selecting. And that could be, we could put that in here. And so, man, it's getting late and I'm getting stupid. Pub fn select parent that's going to take reference to self and this thing. Wow, that is a type. I'm going to really want to give that a name, clearly. And it's going to return, wow, yeah, I'm definitely going to need to give that a type thing because that is nuts. And that's going to return a reference to an individual and that also compiles, much to everyone's amazement. And now, in theory, we should be able to go through, choose a random value between 0 and 1, go through and pick a selector based on that, and then do I want to get into 0 to 32 nonsense, or do I rather do this with integers? Might prefer to do this with integers. So instead of F32s, I wonder if I actually want to just let's do 32 for fun. U32. Now we're going to want to compute the total weight is going to be the selectors dot map. We're going to take a pair, so we could say weight, and the function, which don't care about the name, return the weight dot sum. I thought sum was a thing. Oh, we don't say arrow. Wrong thing. And I didn't like map. Oh, we have to iterate. That always seems weird to me. I feel like if we know it's a vector, we ought to be able to just be able to say dot map. And so then we're going to want to return a let rand we're receiving, select parent needs, it does take self. Yeah, we don't have the random number generator here, which we're going to need. RNG and mute thread RNG. Boom. So now we ought to be able to say RNG dot gen range 0 dot total weight. So now we have a random number in that range. And we will have to pick the first selector where the sum of the weights is greater than or equal to total to the 2R. I feel like there's probably a way to do this with iterators, but I don't immediately know what it is. Oh, and it's like 4 minutes to 9. Let's just be crude about it. Weight and selector in selectors, current weight total plus equals weight if weight greater than R. I really want to just return the selector. Yeah, this is going to be a different function, but whatever. I'm going to have to change the name. Return selector. Actually, just say selector. No, I do need to return because I need to break out of the loop. Return selector. Otherwise, keep going. And we should, and that would be greater than or equal to, because then eventually the total should be, like, if we choose total weight minus 1. Oh no, actually I guess we need, we can get away with just greater than. And that can get rid of this. And so this is actually returning a selector. So one of these, oh my gosh, these things. That's so much I need a name for that. Yeah. And if we bring you down to here, we can bring all of you guys over one. Boo, boo, boo. Now, why are you grumpy? Syntax problem. Box. Oh, that's because we don't want those two guys. Yeah. However, that blew up the world. Oh, that's because it doesn't know that we are guaranteed to return something from here. Ugh. That's really awkward. So we should be able to panic here. We should have found a selector in selector. And this I want to change to selector. And that all compiles. And it's 9 o'clock. Let's quick pub fn select parent self all of this stuff. And that we're going to return a reference to an individual here. And boom, 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 to do, bang. FN, that would help. Okay. Types all work at least. So now we're gonna have let selector be select selector. I'm going to pass it the selectors in the RNG. Okay. Now we ought to be able to call the selector. And so we ought to be able to say selector open paren. We're going to give you a self dot individuals and the RNG. Does that compile? Oh my gosh. That actually compiles. I'm if I assert the length above, then I could use unreachable. So I assume you're talking about down here. So unreachable. And I bet this also takes a string. No. Doesn't? Oh, yes, it does. Okay. So I can put this in here, and unreachable is better than just raw panic. And I could assert that R is less than, well, I mean, it's kind of just given in the definition of gen range. I don't know that asserting that helps here, unless you're suggesting asserting something different. Oh, this should be current total weight. Wow, that's why that's fussing at me. Oh, yeah, that would make sense to assert that we have at least one selector. Selectors dot len greater than 0. We must have at least one selector. Boom. Yeah, good catch. Thank you. And now this ought to let us select parents. Okay, it's after 9, and I know for Isitsu it is super late. The fact that you're still here is a wonderful thing. Thank you so much for staying up so late. I hope this does not cause you great angst tomorrow. I'm going to decide to step away. I mean, one thing we clearly need to do is give this title or this type a name, because man, that is one ugly name, and that would simplify a lot of this. And we probably really want to turn these weighted vectors of weighted pairs actually into their own type. Thank you. Well, I appreciate it. Knowing how late it is for you, that I'm very grateful. Thank you. We probably ought to turn this sort of selecty thingy into its own type with its own methods. And that would also simplify, I think, the readability. So this probably ought to be like a method in some type that is acts on a vector of weighted values. But we're not going to deal with that right now. So I'm going to call this quits. I might cheat and write some tests to see if this even works between now and next week when we return to this, because I feel so close. I'm like, oh, I want to know for sure that this actually works, because the fact that it compiles is cool, and in Rust that actually tells us quite a bit, but it is certainly not a guarantee that it's correct. And also, I feel like there's probably some way of doing this with iterators and some kind of like stepwise reduction thing, instead of using a for loop. But again, it's late. I'm not going to try to solve that. We learned a new feature, HRTBs. I don't know what HRTBs are. Although apparently I learned about them today. Oh, come on, go over here. Higher rank trait bounds. Okay. Oh, and so it's how we handled the lifetimes on the trait bounds. The magic of higher rank trait bounds, which we did in fact use. So, and that was actually coming from you, Izitsu. I did not find that and would not have found it on my own easily. So very, very grateful. Yeah, thank you. That is definitely helpful. So that'll be useful. I should read it and actually make sure I understand what's going on. Okay, it's late. We're all tired. My brain is, I think, turned to mush. I will be back. See, today's Wednesday. I will not be here Saturday morning for the ice-repos stream because we have a climate group meeting Saturday morning that I'm going to attend instead. I will be here Saturday afternoon, however, for the Echo client server stream. And then I should be here Tuesday morning for ice-repos, and next Wednesday for this, picking up where we left off. So that's the plan at the moment. So no Saturday morning stream, but all the other streams should be going as planned. Thank you all so much for being here. Great feedback and suggestions, and is super appreciated. Reminder that this is the Discord link over here on the left in the QR code. Definitely feel free to join the Discord. I will try to write up the pipeline question there, and see if anybody's got any thoughts on that. I might also go over to the Rust users group thing and try to explain what I'm thinking about and see if people there have got any thoughts. Depends on whether I can explain what I'm trying to do without it becoming just too weird for word, but we'll see what we can do. Oh, great. Well, I love to hear your thoughts, but I'll let you get some sleep, and I will talk to everybody later. Thank you all very much. Goodbye.